Good afternoon class. In this video we are going to discuss about TCP. So TCP is a connection oriented protocol where you have to establish connection before sending the data. It is a point to point, one sender and one receiver, no multicasting. It is reliable and it supports stream delivery. Stream delivery means data is sent in the form of stream of bytes. So there are send and receive buffers which keep track of how much bytes are sent and how much are received. There is a full duplex communication. Full duplex means you full duplex means you can at the same time same channel can take data from sender to receiver and also take data from receiver to sender. So both parties can send simultaneously data to each other over the same communication channel. So that is full duplex. Then flow controlled, sender will not overwhelm receiver. So it will not happen like sender is keep sending the data and receiver is not able to control the flow of the data that is coming from the sender. So it's flow controlled. Then congestion control. Congestion control is also one of the property of TCP. We'll see how. Now there are several ports which are well known and are used by TCP. So very important and very well known is HTTP port, which is port 80. Similarly, you have for DNS 53 is port number for 53 is port number for DNS in TCP, and then there are many other port numbers for this. Now you have stream delivery. So in this protocol you have stream delivery. What does that means is you have a sending process and you have a receiving process, and underlying TCP protocol sends streams stream bytes to from one to another in the form of bytes. For example, both the buffers, sender and receiver buffer, keep track of how many bytes are already sent and how many bytes are yet to be sent. So there is a pointer, and similarly in the receiving side there is a buffer which keep tracks of how many bytes are received and how many bytes are delivered to the receiving process or application. Okay, now let's see, there are several things in the TCP including byte number, sequence number and acknowledgement number. So bytes of the data being transferred in each connection are numbered by this TCP. If TCP sender is sending 1000 bytes, so there is a numbering from let's say 1 to 1000 for each byte that sender wants to send. Now it's not necessary that this numbering starts from 1. So it can start from some random number, suppose 9000. So 9000 to 10,000, it will keep numbering its bytes and it will send all those bytes to the receiver. So every byte has a number, okay, arbitrarily generated number. Now the value in the sequence number field of the segment. So segment, as we have discussed, segment is in the transport layer. So the value in the sequence number field of the segment defines the number assigned to the first data byte contained in that segment. The value of the acknowledgement field in the segment defines the number of the next byte that a party expects to receive. So what acknowledgement number I am expecting, so that is acknowledgement number. And then a sequence number is any arbitrary generated number, and after that suppose 1000 bytes are sent, so one by one those bytes are numbered. Suppose, so first sequence number was 9000, as I have given you example already. Second would be 9001, 9002 up to 9999. So total 1000 bytes would be there. Okay, then example is given. Suppose there is a TCP connection and a file is 5000 bytes and 5 segments are sent, each of 1000 bytes, and first byte is number 10001. So 10001 to 11000 would be first segment, second segment would be 11001 to 12000 and so on. Okay, so this is how sequence number for each and every byte in the segment is done. So in a segment, every byte is having a sequence number. Now there is one more concept called MSS, maximum segment size. So suppose maximum segment size is 500, as in previous example maximum segment was 1000. So 5000 bytes if you want to transfer, so you have to make 1000 bytes, 5 segments of 1000 bytes. So maximum segment size is basically defined by underlying layers. For example, your Ethernet may not be able to process a segment of 5000 bytes. So what it will do, it will set, okay, MSS is 1000, so upper layer can only send the at the max 1000 byte segment. Okay, so that is MSS. Now this is the TCP segment structure. We will see how does this works. Now header, we have seen in the UDP segment format. This is TCP segment format. Now in UDP we have already seen that the this header is variable, header is fixed, while in TCP header varies from 20 bytes to 60 bytes. So 20 bytes is the minimum header size and 60 bytes is the maximum header size. Okay, and the length of data plus header is equal to MSS, so maximum segment size. So maximum segment size is described, already defined, and you cannot put the data more than MSS in a segment. Okay, and this header could be 20 to 60 bytes. Now what is the size of the segment, that minimum size of the segment in a TCP? Maximum is defined by MSS, minimum is 20 bytes. So if I am sending only header, that is also a possibility. So minimum is 20 bytes I'll be sending. Now source port address is 16 bit, destination port address is 16 bits. Port through port communication is there. Then sequence number is sequence number of the first byte that I will be sending, and acknowledgement number is the suppose I have sent 9000 to 9999 and I want 10,000, so acknowledgement number would be 10,000 or something. Okay, now HLEN is the header length. Now there is a very interesting concept behind HLEN. Suppose HLEN is 4 bit. Okay, so 4 bit is very less. 4 bit means suppose this was let's say 1100. So 4 bit 1100, if you convert it into decimal, okay, this would be so 1100 would be 8 and 4, that is 12. So at the max in this 4 bit, maximum value would be 1111 and minimum value would be 0000. So what do we do? How do we calculate the length of the header? So we multiply this value in the header length by 4. So 12 fours are 48. So my header length is 48 bytes. Now maximum is 1111. 1111 means 15. So 15 cross 4 is equals to 60. So maximum header length is 60. Now you will say minimum is 0. So 0 cross 4 is 0. So this is wrong. So maximum value that header length can have is 1111 and minimum value that a header length can have is 0101, which is actually 5. So this is 5. 5 cross 4 is equals to 20. So minimum is 20 and maximum is 60. Minimum is 20 and maximum is 60. And rest all those bytes which are 0000, 0001. So 0 to 4, 0000, 0001, 0010, 0011 and 100. These are not defined. So if header length contains that these 4 values, so these are wrong. Okay, so if someone says to you like my header length is 0000, so that is wrong, because minimum header length is 20, which is 5. So it should be 0101. So this is minimum value and this is maximum value. Okay, so this is the concept behind header length. Now next is reserved bit. So next 6 bits are reserved for future use. Then next 6 bits are very important, and these are the flags which defines how your protocol is going to work. Okay, so first one is urgent. So urgent is a bit flag, it is set to 1. This is 1 bit. Urgent flag is 1 bit. So this bit is set to 1 when your data is very urgent and you need to process it immediately, so it will be 1. Acknowledgement is 1 if your segment is your acknowledgement number. Okay, then this is 1. Push is 1 when you don't want your segment to wait in the buffer, you want it to send to push to immediately to application, so that is push. RST is reset. Reset is you want to reset the connection. Syn is whenever you want to initiate the connection. So first packet or first segment that I'm sending should be syn segment. So I want to synchronize. I am initiating a synchronization request to the receiver. Okay, and last bit is fin. Fin means finish. So I want to finish the connection, terminate the connection. Okay, so these 6 bits are the flags. Now next 16 bits are the window size. So window size is suppose 1000. I've set it to 1000. So window size describes at the max I can receive 1000 bytes from the other party. So whosoever is sending me, so if I'm sending something, so no issues, but whenever I'm sending something, I will advertise my window size to the other party that my window size is 1000. Now if you send me more than 1000, your bytes would get dropped and I will not be able to keep it. Okay, so do not make me overflow. So that concept is window size. So this is for flow control. Next is checksum. So checksum we have discussed. So similar work is there. It is for error control. Urgent pointer. Urgent pointer is a pointer to the location after which all the bytes are very urgent. So there's a suppose 0 to 1000 bytes I'm sending, and I have set an urgent pointer to 500. So after 500 remaining bytes are very urgent, and I need it to get processed immediately, so that is urgent pointer. And then furthermore, so 40 bytes. So this initially minimum is 20 bytes. So these things are minimum. These things must have your segment, TCP segment must have these 5 rows. Okay, and remaining are options. Remaining 40 bytes are optional. Okay, so this is all about the TCP segment format. Now sequence number is arbitrarily generated number. We have discussed this. Okay, then header length, you have to multiply those 4 bits by 4 and then you will get header length. Then these are the 6 control fields that we have discussed, 6 flags. Then window size, very very important. So maximum size is 6553 bytes, 2 to the power 16, because it's 16 bit. So maximum is 6553 byte. Now TCP checksum, and this is basically all about TCP segment. Now there's one more concept which is pseudo header. Pseudo header is nothing. Pseudo header, suppose because I need IP address as well as port number. So whenever so I need 2 things for my if for my data to transfer from one person to another, from one sender to another receiving party. So pseudo header is some portion of IP I can read. So because application layer, then you have transport layer, then you have IP layer, right? IP means you have network layer. So some portion of network layer I want to read. So which portion I want to read? I am in transport layer and I am transport layer header, and I am TCP protocol and I want to read IP address as well. So that part which is readable and non-changeable throughout the communication. So non-changeable part, IP layer or network layer makes okay, like you can use it. So that part of network layer which transport layer can use is a pseudo header. Okay, so this is the example. Okay, so some part of IP I can use in the TCP. Okay, which is of course the IP address and source IP address and destination. Now this is the question. This is very important question. So let's see. Okay, so following is a dump of a TCP header in the hexadecimal format. Now what you want to do is find out the source port number. So this is the TCP header given to you. Now hexadecimal means this is 4 bit, 0 is 4 bit, 5 is 4 bit, 4 bit, 4 bit, 4 bit. So this whole portion is what? 32 bits. 8 4s are 32 bits. Now source port number is, so this is source port number 0532 in hexadecimal. Now you need to convert it into decimal. Similarly, this is the destination. Okay, then next is the sequence number, which is this. So sequence number, if you convert it into decimal, you will get 1. So this is the sequence number 1. And then acknowledgement number, this is acknowledgement number. Then you have the length of header. So length of header is 5, right? So 5 4s are 20. So length of header is 20. Okay, 5 4s are 20. Now next 4 bits were 5. Now remaining bits like this, 6 bits over here were reserved. So 0 0 0 0 and 2 bits from here 0. So these 6 are reserved. Then next 6 are flags. So 0 0 and 0 0 1 0. So which type of segment? So which flag is set? So you have to find out which bit is set. So I think second bit is set. So which is sin, second last bit, set second last flag. So which is sin flag. So this flag, if you convert it into this whole into bits, you will get 1 in the sin flag, and which this is the type of sin segment. Okay, what is the window size? So next is the window size. Okay, so that's all about TCP connection. Okay, so now window size is very important, because it indicates how much data I am able to send or receive. So we will start with this tomorrow. Thank you.